Hi, I'm Lozano, CTO of MediaValet, a cloud software company from Vancouver, Canada. Today, I will be talking about the concept of video intelligence and how this can be implemented in a digital asset management system. We all understand the growing importance of videos in marketing. According to a report from HubSpot Research, more than 50% of consumers want to see videos from brands. That's more than any other type of content. Just looking at the stats, 85% of companies now use video as a marketing tool compared to 61% 4 years ago. 92% of marketers say that a video is an important part of their marketing strategy. YouTube's press page, they report that 1 billion hours of videos are watched daily. Companies are investing more and more in videos nowadays, and we all want to make sure that we get as much ROI from video as possible. Unlike images, a video is a compound, multi-dimensional asset. You have a visual component to it in the form of one or more video tracks. You also have an audio component to it, and you have an audio track as well. And these tracks are all time-based. So now let's talk about video intelligence. First of all, video intelligence will analyze both visual and audio components of the video in the context of a timeline and produce insights that will be added to the DAM as cognitive metadata. The goal is to enhance discoverability by enriching metadata and allowing users to search the library for videos and also to search within the video once the asset is opened. An AI service will perform analysis on both the audio and video track, and this analysis will produce insights that will be added as timestamp metadata in the DAM that will be indexed and searchable. The simplest version of AI-based audio analysis is speech-to-text. With speech-to-text, we can perform automated transcription. We can also configure video intelligence to adapt to transcripts to industry, market, or domain-specific terms. We can also do closed captioning in various industry standard formats. Video intelligence can also detect the spoken language from audio and translate them into different languages on demand. In this slide, you will see that a video of my presentation was automatically transcribed by performing audio analysis through machine learning. Then we are able to turn on closed captioning by leveraging the transcript that was automatically generated by AI. And since we're using AI, we can translate to various languages on demand by just clicking and selecting the targeted language. In addition to speech-to-text, we can also extract keywords, infer topics, generate named entities by pulling mentioned people, locations, or brands, and we can run sentiment analysis or detect emotions expressed in speech and vocal signals. Now, let's move on to the visual aspect of video intelligence. Since video intelligence performs a frame-by-frame analysis of the video, we can detect faces and even animated characters. It can also perform celebrity identification from a database of 1 million celebrities around the world. Video intelligence can also be customized to identify specific faces. It can recognize text that appear in video as overlays, slides, or background. It will automatically identify and label objects when they appear. And just like audible content moderation, it will also detect and prevent explicit visual content. Here is an example of the visual AI capabilities. A Henry Stewart video interview where I was discussing with metadata expert John Horodisky about metadata and AI. As you can see, video intelligence was able to identify two people, myself and John. The timeline shows my appearances and when I spoke in the video, and based on the dialogue, it was able to infer topics such as computer science, machine learning, and technology. It was also able to generate what we call labels. When I click on a label suit, The timeline below shows the frames where the object suit was found. And when you click on a particular time block, the video jumps to the corresponding frame in the video. For videographers, editors, and producers, certain video-specific insights could be valuable as well. Scene segmentation has the ability to segment the video by semantic scenes. Shot detection tells us when a shot starts and when it ends based on visual analysis. Shot type detection identifies shots like wide or a close-up shot. Video intelligence can identify rolling credits at the end of the video and also identify black frames in video. Keyframe extraction automatically detects stable keyframes. In the same video example, video intelligence was able to identify 30 scenes, the shots in the current scene and the keyframes in the current shot. So how do all these capabilities translate to the real world? What are the use cases? So far, we have seen a video production agency use the speech-to-text capability in the production process so that they can generate the video transcripts automatically and proof it themselves instead of having to send hundreds of gigabytes of videos to a third-party transcription company. A company in media and entertainment was able to index their videos and raw footage to tag celebrities and animated characters in their repository. Using video intelligence, the discoverability of video assets in their library was exponentially improved. Also, we have seen customers in higher education and those who serve huge volumes of instructional videos use video intelligence to identify speakers or lecturers and infer topics and make transcripts searchable from the various talks that they have. Now that you have seen how video intelligence can be used in a DAM, let us talk about how you can prepare and implement for this. First, you need to make sure that videos are first-class citizens in your DAM. This means that your DAM should have enterprise video capabilities to start with. Ideally, your DAM actually performs video streaming and not just provide progressive downloads of videos. This will give the user the ability to jump to a specific frame by clicking when you select a particular cognitive metadata in the video asset. And a DAM with proper video support should also be able to stream in various bit rates, whether it's 480p, 720p, 1080p, or 4K video. And it should be able to adjust according to the connection that the viewer has. A video streaming service should be able to apply the required protocol that the customer's device has. So the DAM should detect if it's an iPhone, for example, and deliver video through HLS, and then switch to MPEG- if it detects an Android device, right? And of course, just like any other cloud service, it should be reliable, scalable, and secure. Once you have a good foundation for managing enterprise video, you then need to have a metadata structure in your DAM that will support cognitive metadata. Cognitive metadata, unlike conventional metadata, is metadata predicted by AI that extends the structure of traditional metadata. And in the case of videos, cognitive metadata should be time-based. And once you have a solid enterprise video capability and cognitive metadata support, then you can integrate with video AI services offered by various cloud providers. Or if your vendor has already integrated with one, you can use that as well. That's video intelligence in 10 minutes. If you have any questions or if you want to have a discussion about enterprise video support, cognitive metadata, and video intelligence, you can reach out to me and my team at info@mediavalet.com. We are very passionate about the topic of making DAM as intelligent as possible, and we are open to discuss new ideas, use cases, and best practices. Thank you.